A little example using Pascal's principle. So if I have a fluid and the pressure changes at one point in the fluid, Pascal's principle tells us that change in pressure is going to be transmitted throughout the fluid and it won't be diminished. So this is the basis for hydraulic systems, for example. I have an enclosed fluid, and if I push on the fluid at one point with a piston, increase the pressure, then the increased fluid pressure can do work all throughout the hydraulic system. So this example is pushing the brake pedal, and then that's going to cause the rotors on the brake to actuate. And so Pascal's principle is actually just the very beginning of that the pressure at the pedal is going to equal the pressure at the rotor, because any change of the pressure, the piston that the pedal moves, that change in pressure is going to be transmitted all throughout the hydraulic system. Pressure is the force per unit area, so that tells us that the force exerted at the pedal divided by the area of that piston is going to be the force exerted at the rotor divided by the area of the piston at the rotor. And solving for the force exerted at the rotor, we have the ratio of the areas times the force you apply at the pedal. So within a hydraulic system, by tuning the area of the pistons, you can magnify or diminish a force as you like. And this is just like using the work done by a force, in that you're trading off force and displacement. Here I can magnify or diminish a force, but the work done is going to be the same. So a larger area piston won't sweep out the same displacement as a smaller area piston. Alright, so putting in numbers from the problem in the plug and chug stage. It's the ratio of areas, so I'm not going to worry about converting to MKS because it cancels out anyway. So the force exerted at the pedal, 7.5 newtons, gets magnified to 30. And we're also asked for what torque is exerted by the braking system. So there'll be a normal force exerted on the brake, which is what we just found, and the force of kinetic friction, and I'm doubling it because there is a piston on both sides of the rotor. And then the torque, given that force, is there's a force that's exerted on the rotor, and for the torque we need the lever arm, and it was applied at 12 centimeters. So putting that all in, torque exerted on your brake, when you push on the pedal, the force is 7.5 newtons and 5.8 newton meters of torque.